Hello everyone, I'm Kamal Noori and here is Remote Sense Geosciences channel. Today I want to talk about satellite or space platform. Please follow this session. Thanks. But what's the platform? In remote sensing, the platform is the instrument that carries the sensor. In fact, the structure of satellite consists of two main parts: the platform and the sensor. Types of platform based on height. This slide is showing types of platform. Near the Earth is showing ground platform, height less than 3 kilometers. Part 2, aerial platform, heights less than 13 kilometers. And for the Earth, a space platform or satellite, height is on 115 kilometers. A space platform or satellite is located in part 3. Space platform. It is important in remote sensing. Simplified structure of a satellite. Platform, battery case, charger, solar panel, and sensors are three important parts of satellite. This slide is showing inclination angle. But what's inclination angle? The inclination angle is the angle between satellite's orbit and the equator line. Types of satellite orbit based on heights and inclination angle. Geostationary orbit or GEO. Low Earth orbit or LEO. Medium Earth orbit or MEO. Polar orbit and Sun-synchronous orbit SSO. Reference: European Space Agency or ESA site. GEO. Geostationary or geosynchronous orbit. GEO. Satellite in geostationary orbit. GEO circle Earth about the equator from west to east following Earth's rotation, taking 23 hours 56 minutes and 4 seconds by traveling at exactly the same rate as Earth. This makes satellite in GEO appear to be stationary or fixed position in order to perfectly match Earth's rotation. The speed of GEO satellites should be about 3 kilometers per second at an altitude of 35,786 kilometers. This is much farther from Earth's surface compared to many satellites. Geostationary or geosynchronous orbit, GEO. But LEO or low Earth orbit. A low Earth orbit, or LEO, is, as the name suggests, an airport, an orbit that is relatively close to the Earth's surface. It is normally at an altitude of less than 1,000 kilometers, but could be as low as 116 kilometers above Earth, which is low compared to other orbits, but still very far above Earth's surface. Unlike satellite in GEO that must always orbit along Earth's equator, LEO satellites do not always have to follow a particular path around Earth in the same way the plane can be tilted. This means there are more available routes for satellite in LEO, which is one of the reasons why LEO is very commonly used orbit. For example, International Space Station (ISS). LEO's close proximity to Earth makes is useful for several reasons. It is the orbit most commonly used for satellite imaging, as being near the surface allows it to take images of higher resolution. It is also the orbit used for the International Space Station or ISS, as it is easier for astronauts to travel to and from it at the shorter distance. Satellites in this orbit travel at a speed of around 7.8 kilometers per second. At this speed, a satellite takes approximately 90 minutes to circle Earth, meaning the ISS travels around Earth about 16 times a day. MEO, Medium Earth Orbit. Medium Earth orbit comprises a wide range of orbits, anywhere between LEO and GEO. It is similar to LEO in that it also does not need to take a specific path around Earth, and it is used by a variety of satellites with many different applications. SSO, Sun-synchronous orbit. This slide is showing polar orbit and Sun-synchronous orbit, or SSO. Satellites in polar orbit usually travel past Earth from north to south rather than from west to west to east, passing roughly over Earth's poles. Satellites in a polar orbit do not have to pass the north and south pole. Precisely, even a deviation within 20 to 30 degrees is still classed as a polar orbit. Polar orbits are a types of low Earth orbit, as they are at low altitude between 200 to 1000 kilometers. Sun, excuse me, Sun-synchronous orbit, or SSO, is a particular case of polar orbit. Satellites in SSO traveling over the polar region are synchronous with the Sun. This means they are synchronized to always be in the same fixed position relative to the Sun. This means that the satellite always visits the same spot at the same local time. For example, passing the city of Paris every day at noon exactly. This means that the satellite will always observe a point on the Earth as if constantly at the same time of the day, which serves a number of applications. For example, it means that scientists and those who use the satellite images can compare how somewhere changes over time. This slide is showing polar orbit in Earth resources satellite, such as Landsat and Spot. A satellite in a sun-synchronous orbit would usually be at an altitude of between 600 to 800 kilometers. At 800 kilometers, it will be traveling at a speed of approximately 7.5 kilometers per second. But this slide, the number of pass orbits in the sun-synchronous satellite. This number 3, 4, 5 are orbit number or pass of satellite. And this slide, an example of a numbering system for row, north to south, and pass, east to west in index map. For example, 160, 170, 180 are showing pass, and 5, 10, 15, 20, 25 are showing row. This slide is showing index map of Landsat 7, the number of pass and row for Fars province, Iran. For example, 163, this is pass. 38, this is row. And another row and pass. And final slide, a nice picture from James Webb Space Telescope. Many thanks for your attention.